Moving to the last topic of pericyclic reaction, group transfer reaction. That is the fourth type. Group transfer first reaction that we discussed is electrocyclic reaction, then cycloaddition, then sigmatropic. Fourth one, group transfer reaction or Ene reaction. Very important. Ene reaction. We have to discuss about Ene reaction, its regioselectivity and the intramolecular Ene reaction and some factors. Okay, a small topic. So what's the Ene reaction? Ene reaction. You are familiar with this reaction. A diene plus dienophile under thermal condition, which is a 4+2 cycloaddition reaction. What will be the reaction? Here a cyclic adduct is formed. So your product will be a 6-membered ring with one pi bond. This is simply a 4+2 cycloaddition reaction. You are familiar with this reaction, Diels-Alder reaction or the 4+2 cycloaddition reaction. This is the diene and it's a dienophile. Dienophile means diene loving species is called dienophile. Okay, to form the cyclic product. Instead of, here two double bonds are there. Instead of one of the double bond, I am taking an allylic hydrogen. This is an allylic carbon, 1, 2, 3. This is an allylic carbon and it's an allylic hydrogen. Okay, this resembles the diene plus an enophile. Okay, this is an allylic system and this is an enophile. My dear students, what will be the reaction? Both of these resemble. Here two double bonds are there. Instead of one double bond, an allylic hydrogen is there. The reaction is this allylic carbon hydrogen bond will make a pi bond here. This is shifted towards here. This bond catch up this hydrogen. Okay, allylic carbon hydrogen bond make a pi bond here. So reaction taking place same thermal condition. Here a pi bond is formed. Okay, then that is connected to the carbon, this carbon. Okay, then the hydrogen is transferred to this one. So the allylic hydrogen is transferred. You can give a number. This is carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5. Same carbon number 1, 2, 3, 4, 5. Before the reaction, the allylic hydrogen is at carbon number 1. After the reaction, that hydrogen is transferred to carbon number 5. Okay, allylic hydrogen at carbon number 1 is transferred to carbon number 5. That is called as group transfer reaction or an Ene reaction. Okay, so between 1 and 2 a pi bond, then 3, 4, 5 carbon atom. So in the reactant 1 plus 1 2 pi bond is there, but in the product only 1 pi bond is there. So one of the pi bond is converted into a new sigma bond. Okay, so this type of reaction is called as Ene reaction or group transfer reaction. It is similar to the 4+2 cycloaddition reaction. Okay, so an allylic hydrogen, an allylic system plus a enophile. Reaction only thermal condition. Under photochemical condition, this may be a 2+2 cycloaddition reaction. You know 2+2 cycloaddition reaction takes place under photochemical condition. Here two pi bonds are there. Under photochemical condition, this may be a 2+2 cycloaddition reaction. So Ene reaction takes place under thermal condition. It's a core point. The same reactant under photochemical condition may be a 2+2 cycloaddition reaction, but Ene reaction takes place under thermal condition. Okay, so we can move to some examples. Some examples of Ene reaction. So write the first question. Question 1. Okay, plus an enophile under thermal condition. Dear students, what will be the reaction? What will be the reaction? Here it's an allylic carbon and that allylic carbon containing a hydrogen. So it's an allylic system and enophile. Allylic system and enophile condition, thermal condition. So definitely in reaction, this allylic bond shift towards here, this will towards here, this pi bond catch up this hydrogen. So your product will be between these two carbon a pi bond, at this carbon a methyl group is there, then here a single bond, that carbon is connected to this one, and the hydrogen is transferred to this carbon. You can give the same number system, 1, 2, 3, 1, 2, 3. At 2 a methyl group is there, 3 is connected to 4, 5. 3 is connected to 4, 5. The hydrogen at the first carbon is transferred to fifth carbon. The hydrogen at the first carbon is transferred to fifth carbon. So this is what type of reaction? In reaction. Clear? Then next example, next question. Please write. Question number 2. Plus COOR under thermal condition. What will be the reaction? Definitely it's an in reaction because 1, 2, 3 here an allylic hydrogen is present. Allylic hydrogen. The hydrogen at the third carbon is called, if you are numbering from double bond, the hydrogen at the third carbon is called allylic hydrogen. So allylic hydrogen plus an enophile. So definitely in reaction. What will be the reaction? This carbon hydrogen sigma bond will make a pi bond here. This shift towards this carbon and this catch up the hydrogen. So what will be your product? The 6-membered ring as such present. Here single bond. Here a new pi bond is formed. This carbon is connected to these two carbons. First carbon containing a COOR group. Second carbon also a COR. Hydrogen is transferred to this side. You can give a number. This allylic carbon has 1, this is 2, this is 3, this is 4, this is 5. Here also 1, 2, 3, 4, 5. Between 1 and 2 a pi bond is formed. 3 is connected to 4 and 5. 3 is connected to 4 and 5. At 4 and 5 a COOR is present. The hydrogen at the first carbon is transferred to fifth carbon. That will be the product. Clear? Okay. Question number 3. Third question. Please write the third question. A 5-membered ring plus C double bond O. This is a malic anhydride. It will also act as an enophile. What will be the reaction? Here an allylic hydrogen is present. 1, 2, 3. Yes, an allylic hydrogen. So an allylic system plus enophile under thermal condition. What will be the reaction? Definitely it's an in reaction. This carbon hydrogen sigma bond will make a pi bond here. This connected to this carbon. This will catch up this hydrogen. You can give a number. Allylic carbon 1, 2, 3, 4, 5. Okay. So between 1 and 2 a pi bond is formed. This third carbon, this is the third carbon that is connected to the malic anhydride system. Double bond O, and hydrogen is transferred to this carbon. Please give the number. This is 1, 2, 3, 4, 5. Is it? Okay. Between 1 and 2, a pi bond is there. 3 is connected to 4 and 5. 3 is connected to 4 and 5. The hydrogen at the first carbon is transferred to fifth carbon. Okay. Fourth example. Fourth example. Plus okay, under thermal condition. Under thermal condition, what will be the reaction? What will be the reaction? Here 1, 2, 3, this is an allylic carbon, and that allylic carbon containing a hydrogen. Allylic carbon containing a hydrogen. So give a number. This is 1, this is 2, this is 3, this is 4, and it's a 5. It's a 5. What will be the reaction? This carbon hydrogen sigma bond will make a pi bond here. This connected 3 is connected to 4. Carbon number 5 catch up the hydrogen. So your product will be between 1 and 2 a pi bond is formed. Between 1 and 2 a pi bond is formed. This is 3. 3 is connected to 4 and 5. 3 is connected to 4 and 5. Okay. And this fifth carbon containing the transferred hydrogen. At carbon number 3 a methyl substituent is there. Then giving number, this is 1, 2, 3, 4, 5. Initially the allylic hydrogen is at carbon number 1. After the ene reaction, it is transferred to carbon number 5. Between 1 and 2 a pi bond. At carbon number 3 a methyl substituent is there. 3 is connected to 4 and 5. Clear? So that will be the reaction. Then one more example. Example 5. Plus aninophile COOR under thermal condition. What will be the reaction? 1, 2, 3, an allylic carbon is present. That allylic carbon containing a hydrogen also. So allylic system plus enophile. An ene reaction. What will be the reaction? Carbon hydrogen sigma bond will make a pi bond here. This towards here. So give the same number. 1, 2, 3, 4, 5. Okay. So between 1 and 2 a pi bond. Then 2 is connected to 3, 3 is connected to 4, 4 is connected to 5. Between 4 and 5, 1 pi bond is still remaining. Here a COOR is present. Here also a COOR is present. That fifth carbon catch up the hydrogen. So give a number 1, 2. Between 1 and 2 a pi bond is there. Then 3 is connected to 4 and 5. Between 4 and 5 a pi bond is there. 2 COR. The hydrogen at the first carbon is transferred to fifth carbon. So these are some examples of ene reaction. Okay, then regioselectivity in group transfer reaction. Regioselectivity in group transfer reaction. Okay, what will be the regioselectivity? Please listen. For example, it's an allylic system because here an allylic carbon is present. This is the allylic carbon and that carbon containing a hydrogen also. On reaction with double bond CHO. Here your enophile is an unsymmetrical enophile. So whenever your enophile is unsymmetrical, definitely regioselectivity is there. Okay, whenever your enophile is unsymmetrical, regioselectivity is there. Here the possibility for two products are there. What are the two possible products? What are the two possible products? First possible product, this carbon hydrogen sigma bond shift towards here, this towards here, this catch up the hydrogen. So your first product will be double bond CHO and hydrogen transferred to this carbon. That will be your first possibility. Second possibility, just reverse the enophile. Just reverse the enophile. That means enophile is reverted. CHO. Then same reaction. Carbon hydrogen sigma bond shift towards here, this catch up the hydrogen. All this reaction takes place under thermal condition. So your product will be double bond. Here CHO, here a hydrogen. My question, whether the product 1 and the product 2 are same or not. Product 1 and 2 is not same. So which product will be the major product? That is regioselectivity. Okay, which product? Here your dienophile is an unsymmetrical dienophile. Okay, so this carbon, you can give a number 1, 2, 3. This carbon number 3 is connected to the CHO bearing carbon or the neighboring carbon. The carbon number 3 is connected to the CHO bearing carbon or the neighboring carbon. That is your question, because dienophile is unsymmetrical. So how you can find the major product? Please listen. How you can find the major here? This is the allylic system. Due to resonance, the electron density is at the third carbon, delta minus 1, 2, 3. The negative charge or the pi electron density is concentrated at the third carbon. Okay, due to this allylic hydrogen, due to the resonance, it is actually hyperconjugation. Okay, due to the hyperconjugation of this allylic hydrogen, the electron density is concentrated at the third carbon. Clear? Plus double bond C double bond OH. That is your aldehyde. Here also due to resonance, a positive charge will be developed not to the electron withdrawing group bearing carbon, next to neighboring carbon. A positive charge is developed at the beta carbon of electron withdrawing group. This is CHO is electron withdrawing group. That connected carbon is alpha. Neighboring carbon is beta. So always whenever an electron withdrawing group is present in a molecule, a positive charge will be generated at the beta carbon due to resonance. Okay, then my question, what will be the regioselectivity? Always electrostatic interaction between positive and negative. So your product will be this is the allylic system plus enophile CHO. Due to this hydrogen, electron density at this carbon. Due to the CHO, positive charge at this carbon. So definitely the reaction will be like this. So under thermal condition, your product will be, here a double bond is formed. At this carbon, a CHO group is present and a hydrogen is also present. So that will be your product. Interaction is between these two carbons. So that is the regioselectivity. Due to hyperconjugation, the electron density of carbon hydrogen sigma bond is concentrated at the third carbon, and that will interact with the positively charged carbon. Okay, so please write some questions. Question number 2. Plus double bond COR under thermal condition. Here your enophile is unsymmetrical, so definitely regioselectivity is there. Here an allylic carbon is there. This is the allylic hydrogen. Due to this hydrogen, electron density is concentrated at the third carbon, and that will interact with the positively charged carbon. So this will be the regioselectivity. What will be the reaction? Carbon hydrogen sigma bond will make a pi bond here. This will interact with the positively charged carbon. This pi bond catch up the hydrogen. So what will be your product? What will be your product? A 6-membered ring as such. Here a pi bond is formed between 1 and 2. This third carbon is connected to this one, and here a COOR is present, and also a hydrogen. Clear? You can give a number system 1, 2, 3, 4, 5. Here also it's a 1, 2, 3, 4, 5. Between 1 and 2 a pi bond is there. 3 is connected to 4. At carbon number 5 a COOR, hydrogen is transferred to carbon number 5. So that will be your product. So this will be the regioselectivity of the reaction. Okay, the next question. Third question. Third question. Plus okay, under thermal condition, what will be the reaction? Here an allylic carbon is present. This is the allylic carbon, and that allylic carbon containing a hydrogen. So an allylic system plus an enophile. Okay. So due to this hydrogen, the negative density at this carbon, due to the withdrawing group C double bond O, positive charge at this carbon. So what will be the interaction? What will be the interaction? This carbon hydrogen sigma bond to make a pi bond here. This will connect it to that carbon, and this pi bond to catch up the hydrogen. So what will be your product formed? The 5-membered ring as such present. Okay, between these two carbon a pi bond. This carbon is connected to the enophile Z double bond O. Here a hydrogen is set. So give the number 1, 2, 3, 4, 5. Between 1 and 2. 1, 2, 3, 4, 5. Between 1 and 2 pi bond. 3 is connected to 4 and 5. At 5 the hydrogen is transferred. Allylic hydrogen is transferred. So that will be the regioselectivity. Clear? Then another question. Question number 4. Question number 4. Plus CHO under thermal condition. What will be the reaction? Here two allylic carbons are there. This is also allylic carbon. This is also allylic carbon. Both are identical. So I am considering this allylic carbon, that allylic carbon containing a hydrogen. Due to this allylic hydrogen, hyperconjugation will create an electron density at the third carbon, 1, 2, 3. Here negative charge. Due to the CHO, here a positive charge. So these two carbon will interact. So what will be the reaction? This carbon hydrogen sigma bond shift towards here, this towards here, this catch up the hydrogen. So what will be your product? Between 1 and 2 a pi bond. This 3 containing one methyl group. 3 is connected to the enophile. This carbon containing a CHO group, and one more hydrogen is transferred. So that will be your product. Absolutely, that will be your product. Okay, you can give a number. This is 1, this is 2, this is 3. This is 1, this is 2, this is 3. Between 1 and 2 pi bond. At carbon number 3, one methyl substituent is there. 3 is connected to 4 and 5. 3 is connected to 4 and 5. At the fifth carbon, a CHO group is present. This hydrogen is transferred to fifth carbon. Okay, so that will be the product, regioselectivity. Okay, then another question. Another question. Plus COO R. COO R. Okay. Here also two allylic carbons are there. Two allylic carbon. This is also an allylic carbon. This is also an allylic carbon. So I am considering this carbon, this allylic carbon containing a hydrogen. Allylic carbon containing a hydrogen. Due to this hydrogen, hyperconjugation will create an electron density at the third carbon, and due to the COR, this is positive. Then what will be the reaction? This carbon hydrogen sigma bond shifted towards here. This will interact with this carbon. Here that pi bond will catch up the hydrogen. Reaction taking place under thermal condition. So between 1 and 2 a pi bond is there. This is carbon number 3. 3 containing a methyl group. 3 is connected to the enophile. Enophile is a cyclic 5-membered system. Here a COOR group is present and one hydrogen is also transferred to that group. Give a number, then you get an idea. 1, 2, 3. Between this is 1, 2, 3. Between 1 and 2, a pi bond is formed. At carbon number 3, a methyl group is there. 3 is connected to 4 and 5. 3 is connected to 4 and 5. At the carbon number 5, a COR is present. The hydrogen at the first carbon is transferred to fifth carbon. So that will be your product. So whenever your enophile is an unsymmetrical enophile, definitely regioselectivity will be there. Okay, then another case of regioselectivity. Another case of regioselectivity. Please consider this question. Plus double bond CHO under thermal condition. Here your enophile is unsymmetrical. Enophile unsymmetrical, definitely regioselectivity is there. At the same time, here two alpha carbons are there. In the previous question, both alpha carbons are identical, but it is not identical. Two alpha carbons are there. My question, this alpha carbon also containing hydrogen, this alpha carbon also containing hydrogen. Which hydrogen is considered? Which hydrogen is considered in reaction? Okay, when your allylic system, in the allylic system having more than one allylic carbon which are not identical, in such cases which allylic carbon that you have to consider? That is my question. The key point, when allylic system with more than one allylic carbon, when allylic system with more than one allylic carbon, that carbon containing maximum hydrogen will participate in reaction. That is the key point. Very important. If more than one allylic carbon is there, they are not identical, then which hydrogen will participate? That carbon containing maximum hydrogen. Dear students, here two hydrogens are present. At this carbon, two allylic hydrogen. At this carbon only one hydrogen. So definitely this carbon or this allylic carbon will participate in reaction. Okay, because that will provide more electron density at the third carbon due to hyperconjugation. That is the reason. Okay, so that carbon containing maximum hydrogen will participate in reaction. So what will be the reaction? Due to the CHO, here a positive charge, so that will be the regioselectivity. So this carbon hydrogen sigma bond will make a pi bond here, this towards here, this catch up the hydrogen. So your product will be, what will be your product? The 6-membered ring as such. Between these two carbon a pi bond, this is connected to the enophile, this containing a CHO group, and the hydrogen is transferred to this carbon. Giving number, this is 1, this is 2, this is 3, this is 1, 2 and 3. Between 1 and 2 a pi bond is there, here a methyl group is there, 3 is connected to 4 and 5, 5 containing CHO and hydrogen is transferred to that 5th carbon. Okay, so that will be your product. So regioselectivity is in two cases, when enophile is unsymmetrical or when more than one allylic carbon is present. Both the case you have to consider the regioselectivity. Then please write the next question. Another question. Next question. Double bond plus double bond O. Here enophile is unsymmetrical as well as two allylic carbon is there. This is also an allylic carbon, this is also allylic carbon. But this carbon containing maximum hydrogen, so that hydrogen will participate in reaction. Those allylic carbon with the maximum hydrogen will participate in reaction. So what will be the reaction? With respect to this allylic hydrogen, here a negative density. Due to this withdrawing carbon, here a positive density. This towards here, this towards here, this will catch up the hydrogen. So what will be your product? Reaction takes place under thermal condition. Your product will be a 5-membered ring. Here a methyl group is there. Between these two carbon a pi bond. This carbon is connected to the enophile. Enophile is a 6-membered ring system. Here a double bond, hydrogen transferred to this carbon. So that will be your product. We can give a number 1, 2, 3. This is 1, 2, 3. Between 1 and 2 a pi bond. 3 is connected to 4 and 5. 3 is connected to 4 and 5. The hydrogen at the first carbon is transferred to 5th carbon. Hydrogen at the first carbon is transferred to 5th carbon. So that's a group transfer reaction. Okay. Then next question. Next question. Please write one more question. Plus double bond COOR under thermal condition. Enophile is symmetrical, but here two allylic carbons are there. This is also an allylic carbon. This is also an allylic carbon. Which carbon will participate? Here two hydrogens are present. At this carbon, two hydrogens are present. This is CH3, this is CH2. Here 3 hydrogen, here 2 hydrogen. Those allylic carbon with the maximum hydrogen will participate in reaction. So definitely this hydrogen will participate. Due to this, here a negative density that will interact with, both are identical. Okay. So what will be the reaction? This carbon hydrogen sigma bond to make a pi bond here. This towards here, this will catch up the hydrogen. So what will be the product between these two carbon a pi bond, which is connected to the third carbon, that is connected to the enophile containing COOR. Here an ethyl substituent is there. Okay, you can give a number. Give a number 1, 2, 3. 1, 2, 3. Between 1 and 2, a pi bond, 3 containing an ethyl substituent, it is connected to 4 and 5. Which is connected to 4 and 5. So that will be your final product, and the hydrogen is transferred to this carbon. Hydrogen is transferred to fifth carbon. So that is about the regioselectivity of ene reaction. Next one, intramolecular ene reaction. Intramolecular ene reaction. Intramolecular ene reaction. Okay, so please listen. In intramolecular ene reaction, both the allylic system and enophile present in the same molecule. Both the allylic system and enophile present in the same molecule. So please listen. Please listen. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Clear? Here an allylic carbon. This is an allylic carbon. CH3. It's an enophile. Okay. So an allylic system. This is an allylic system and enophile both are present in the same molecule. Reaction thermal condition. Reaction thermal condition. This is also an allylic carbon, but it's a CH2. It's a CH3. Those with the maximum hydrogen will participate. Okay. So an allylic system and enophile present in the same molecule, that is called as intramolecular ene reaction. First of all, you have to give a number. Giving number. This is 1, this is 2, this is 3, this is 4, 5, 6, 7, 8. 8 carbon. 6, 7, 8 carbon. So this is the allylic system and this will be the enophile. Okay, this will be the enophile. So you can take it as separate. The allylic system. What will be the number? This is carbon number 7, 6, 7, 8. This is carbon number 8. This is 7, 6 plus enophile. Enophile is 1, 2. Enophile is 1, 2. Okay. What will be the reaction? And between or 1, 2. Between 6 and 2, this is 6th carbon and this is 2nd carbon. Between 6 and 2, a carbon chain is there. You can represent like this. Between 6 and 2, a carbon chain is there that we can represent in the product. Condition under thermal condition. What will be the reaction? This carbon hydrogen sigma bond shifted towards here. This will make a new bond with this one. This hydrogen shifted towards that carbon. So what will be your product? Here a pi bond is formed that is connected to next carbon. Here a hydrogen. Giving the same number 876. 6 is connected to 2, 1. Okay. Between 8 and 7 a pi bond is formed. 6 is connected to 2 and 1. Between 6 and 2 how many carbons are there? Between 6 and 2 1, 2, 3 carbons are there. Okay. In the reactant between 6 and 2 1, 2, 3 carbons are there. That can be represented like this. 1, 2, 3 carbon. So that will be your final product. Between 6 and 2, this is 5, this is 4, this is 3, 2, 1. So after the ene reaction, that will be your product. So both allylic system and enophile in the same molecule. Okay. Then next question. Question number 2. Question number 2. Here COOR, and it's an allylic system. So both allylic system, this is the allylic hydrogen, allylic carbon and that hydrogen. Allylic system and the enophile in the same molecule, reaction taking place under thermal condition. Definitely it will be an ene reaction. How you can find the product? How you can find the product? Giving number, this is 1, 2, 3, 4, 5, 6, 7, 8. Okay. You can take the enophile and allylic system separately. This will be your allylic system. What is the number? 876. 876 plus in the enophile regioselectivity is there. Regioselectivity is there. With respect to this hydrogen here, negative density. So that will interact with the positive density. COOR, this is positive charge, and it is 2, it is 1. Okay, 2 and 1. Then what will be the reaction? What will be the ene reaction? Between 6 and 2, this is 2, 6, a carbon chain is there. Between 6 and 2, a carbon chain is there. That we can fill later. So the reaction is this carbon hydrogen sigma bond to make a pi bond here. This towards here, towards here. So your product under thermal condition, what will be the product? A pi bond which is connected to a carbon. Here a COOR group is present and the hydrogen is transferred to this carbon. Okay, group transfer reaction. Between then again give the number. This is 8, 7, 6, 2, 1. Between 6 and 2, 1, 2, 3 carbons are there. 1, 2, 3 carbon. 1, 2, 3 carbon. So that will be your final product. Between 6 and 2, 3 carbon. So that will be your product. What about the number? 5, 4, 3, 2, 1. So this type of question that you can expect, which is called as intramolecular ene reaction, when allylic system and enophile is present in the same molecule. Okay. Then write the next question. Next question. Third question. A 6-membered ring. Here a double bond. Then 1, 2, COO under thermal condition. What will be the reaction? 1, 2, 3. This is an allylic carbon and this allylic carbon containing a hydrogen. This is also allylic carbon, but this is with maximum hydrogen. So an allylic system and enophile in the same molecule, intramolecular ene reaction. Allylic system and enophile in the same molecule, intramolecular ene reaction. Okay, giving number, you can give a number. This is 1, 2, 3, 4, 5, 6, 7. 6, 7. So take the allyl system and enophile separately. Allyl system. This is the allyl system containing a hydrogen. Okay, plus enophile COOR. Regioselectivity is also there. Then the remaining portion of the allyl system, a 6-membered ring. Give the same number 1, 2, 3, 4. This is 6, 7. Okay. So between 4 and 6, a carbon chain is present. Between 4 and 6, a carbon chain is present. Then write the product under thermal condition. Between 4 and 6, a carbon chain is present. What will be the product? this carbon hydrogen sigma bond shift towards here, this towards here, this will make a new bond. Here this is the negative density and this is the positive density, that is the regioselectivity. Okay, then what about the product? What about the product between these two carbon? A pi bond that is connected to this carbon. Here ZOOR and hydrogen transferred to that carbon, then remaining portion of the ring, what about the number 1, 2, 3, 4, this is 6 and 7. Between 4 and 6, how many carbons are there? Between 4 and 6, one more carbon is there. Between 4 and 6, one more carbon is there. That will be the one carbon. This is 5, 6. Okay, 5, 6. So this is also a 6-membered ring. 1, 2, 3, 4, 5, 6. So this product is equivalent to 2 6-membered ring. 1 6-membered ring already present, one more 6-membered ring. At this carbon, a double bond. Then 1, 2, 3. 1, 2, 3. Third carbon containing a carbon with the COOR and hydrogen. A carbon with the COOR and hydrogen. So I think that will be your final product, absolutely. Okay, 2 6-membered ring, double bond, then 1, 2, 3, 1, 2, 3, third carbon with the COOR and hydrogen. So that will be your final product. So that's all about intramolecular ene reaction. Next one, sometimes heteroenophiles are also used. Heteroenophiles. Okay, heteroenophiles. Two popular heteroenophiles are, first one, a carbonyl compound, C double bond OR. Carbonyl compound can act as enophile, heteroenophile. Second one, selenium dioxide. Selenium dioxide is a very important reagent used for allylic oxidation. Okay, that we will study in this lecture. Okay, so two popular heteroenophiles are carbonyl compound and selenium dioxide. So we can start with the carbonyl compound will act as heteroenophile. So write a question. It's an allylic carbon and that carbon containing a hydrogen. So system is allylic system. On reaction with a carbonyl compound. Reaction generally taking place under thermal condition, because ene reaction taking place under thermal condition and in the presence of a Lewis acid. A Lewis acid will facilitate the reaction. What are the common Lewis acid? AlCl3 act as a Lewis acid, BF3 act as a Lewis acid, SnCl4 act as a Lewis acid. These are some common examples of Lewis acid. Okay, so an allylic system plus enophile, but here carbonyl compound can also act as an enophile. That is the question. Okay, so thermal condition, what will be the reaction? Carbon hydrogen bond is shifted towards here, this towards the carbonyl carbon, and C double bond catch up the hydrogen. So your product will be double bond, a carbon, this is connected to the enophile, this carbon containing 2 R group, this become OH. So an alcohol will be your final product. Okay, an alcohol will be your final product. You can give a number. This is 1, this is 2, this is 3. 1, 2, 3. Between 1 and 2, a pi bond. 3 is connected to 4 and 5. 3 is connected to 4 and 5. Fourth carbon containing 2 R group. Fifth carbon O. That O become OH. So that is, this is also an example for an ene reaction. Example 2. Second example. PH, CHO, a Lewis acid thermal condition. This will be the reaction. PHCHO, Lewis acid thermal condition. Dear students, is it an allyl system? 1, 2, 3. Yes, it's an allyl system. This is the allylic hydrogen. PHCHO is an aldehyde, a carbonyl compound. PHC double bond OH. So carbonyl compound will act as enophile. It's here an allylic hydrogen is present. What will be the reaction? And in the presence of Lewis acid, an ene reaction. This bond shifted towards here, this towards here. This will catch up the hydrogen. So what will be your product? What will be your product? Between these two carbon, a pi bond is formed. This carbon is connected to the carbonyl carbon, and this is O. Here a PH and an H is present. O become OH. Here a methyl group is present. So that will be your final product. You can give a number. Give a number. This is 1, this is 2, this is 3. 1, 2, 3. Between 1 and 2, pi bond. At carbon number 2, a methyl group. 3 is connected to 4 and 5. 3 is connected to 4 and 5. At 4th carbon, a PH and H. 5th carbon become OH. So that will be your final product. So this is also an example for ene reaction. Ene reaction. Okay. Then third example. Third example. Double bond plus PH C double bond OH. First step BF3 under thermal condition. Second step PCC and H plus. PCC and H plus. What will be the product? It's a heteroenophile. Here an allylic carbon is present. So allylic system plus enophile, definitely it's an ene reaction. Ene reaction. What will be the reaction? What will be the reaction? This carbon hydrogen bond is shifted towards here. Okay. This towards here. This bond to catch up the H plus. That will be the reaction. That will be the reaction. Reaction taking place under the presence of BF3. What will be the product? The 5-membered ring as such present. This is a carbon. That carbon is connected to the carbonyl carbon. That carbonyl carbon containing a PH and the H. This become OH. And between these two carbons, a pi bond is there. Okay. Give a number 1, 2, 3. 1, 2, 3. Between 1 and 2, a pi bond. This 3 is connected to 4 and 5. 3 is connected to 4 and 5. 4th carbon containing a PH and H. 5th carbon containing OH. Okay. So that is your product. Then next step PCC. PCC. Pyridinium chlorochromate. It's an oxidizing agent. Alcohol is oxidized to carbonyl compound. C double bond O H. C double bond O PH. C double bond O pH. That alcohol is converted into carbonyl compound. Then one more reagent is given, which is an H plus. What is the function of that H plus? First step is an ene reaction. This is an ene reaction. Second step, oxidation by using PCC. PCC oxidize alcohol to carbonyl compound. Then one more H plus is given. H plus. Dear students, it's a carbonyl compound, and this alkene is an isolated alkene. This alkene is an isolated alkene. Okay, isolated alkene. Because you know, consider these two types of alkene. C double bond O H. C double bond O, not H, it is PH. PH is given. This is alpha beta. First alkene is an isolated alkene. First alkene is an isolated alkene. Second alkene is a conjugated alkene. Conjugated alkene. You know, conjugated alkene is more stable than isolated alkene because in conjugated alkene resonance is possible. It's an isolated alkene. This is alpha beta unsaturated carbonyl compound. It's not an alpha beta. This is beta gamma unsaturated. So a beta gamma unsaturated carbonyl compound can be converted into alpha beta unsaturated in presence of H+. That reaction is called as isomerization reaction. Okay, that reaction is called as isomerization reaction. The mechanism of the reaction that we will discuss in the reaction mechanism section. Okay, so whenever a beta gamma unsaturated carbonyl compound is there in presence of H+, isomerization reaction taking place and it is converted into a more stable conjugated alpha beta unsaturated carbonyl compound. Okay, very important. Whenever your product is a isolated alkene in the question paper, an H+, additional H+, an extra H+ is there. In the presence of that extra H+, this alpha beta gamma unsaturated carbonyl compound is converted into more stable alpha beta unsaturated carbonyl compound. This is a conjugated alkene which is more stable, and this reaction is called as isomerization reaction. That reaction is called as isomerization reaction. Very important. Then another question. Next question, a 6-membered ring. Here a double bond is present plus formaldehyde HC double bond to OH. First step, BF3 which is a Lewis acid under thermal condition. Second step, PCC. Third step, an extra H+. Next question, please write one more question. A 6-membered ring. Here an allylic carbon is present. C double bond to OH. So intramolecular reaction. First step, AlCl3 under thermal condition. Second step, PCC bar H+. Extra H+ is also given. So here carbonyl compound and the allylic system is given in the same molecule. These two questions you can do it as a homework because our time is very short. So you have to work it as a homework. It's an intramolecular reaction. The enophile and allylic system in same molecule. It's a heteroenophile, carbonyl compound heteroenophile reaction, generally in the presence of a Lewis acid. Extra H+ is there, that is isomerization taking place. Isolated alkene is converted into conjugated alkene. Okay, then selenium dioxide is a useful reagent. Selenium dioxide as heteroenophile. It's a very useful reagent. For example, you have an allylic system. It's an allylic hydrogen. On reaction with selenium dioxide, SiO2. In the second step, TBuOOH, tertiary butyl hydrogen peroxide. So selenium dioxide is a typical reagent used for the oxidation of allylic hydrogen to OH. Selenium dioxide is a typical reagent used for the oxidation of allylic hydrogen to OH. That means this allylic hydrogen is oxidized to an OH alcohol. The reaction taking place through First step, an ene reaction. Second step, a 2,3 sigma tropic rearrangement. This is a question of many chemistry related competitive exam. The oxidation by using selenium dioxide is a consecutive reaction of an ene reaction and a 2,3 sigma tropic rearrangement. Mechanism I will explain. What is the application of this reagent? Selenium dioxide, tertiary butyl hydrogen peroxide. What is application? Wherever an allylic hydrogen is present, that hydrogen is oxidized to an alcohol. So what will be your product? That allylic hydrogen is oxidized to an OH. Allylic hydrogen is oxidized to an OH. That is the function of this. Tertiary butyl hydrogen peroxide is used to regenerate the SiO2 after the reaction. That is the role of tertiary butyl hydrogen peroxide. It is used to regenerate the SiO2 after the reaction. All the aspects that we will study in the reagent section. Okay, so here the important point is this oxidation takes place through two steps. First step is an ene reaction. Because selenium dioxide acts as a heteroenophile. First step is an ene reaction followed by a 2,3 sigma tropic rearrangement. Give a star mark, an important question of many competitive exams and also many interviews. Okay, oxidation using SiO2 followed by ene reaction followed by 2,3 sigma tropic rearrangement. Okay, so please write a question. Mechanism I will explain. Then write some questions. Then only you get an idea about the application of this reagent. The first question, an allylic system. Okay, on reaction with selenium dioxide and tertiary butyl hydrogen peroxide. Where is allylic carbon? This is an allylic carbon, and that carbon containing a hydrogen. That hydrogen is oxidized to an OH. Then next question, an allylic system on reaction with selenium dioxide and tertiary butyl hydrogen peroxide, TBuOH, tertiary butyl hydrogen peroxide. Where is allylic carbon? This is the allylic carbon. That carbon containing a hydrogen that is oxidized to an OH. These all reactions, the mechanism of this reaction followed two steps. First step is an ene reaction and second step is a 2,3 sigma tropic rearrangement. Another question. A 6-membered ring system. Here a double bond is there. On reaction with selenium dioxide and tertiary butyl hydrogen peroxide. What is the this is an allylic carbon. That carbon containing a hydrogen. That hydrogen is oxidized to an OH. So that will be the mechanism of the application of the reagent. Okay, mechanism follows two steps. First step is an ene reaction. Second step is a 2,3 sigma tropic rearrangement. So always the allylic carbon is oxidized to an OH. Okay. So mechanism of the reaction. More applications of selenium dioxide we will discuss in the reagent section. Okay, mechanism, please listen. It's an allylic system plus selenium dioxide, Sc, double bond O. Condition thermal. Selenium dioxide acts as a heteroenophile. What will be the reaction? This carbon hydrogen sigma bond to make a pi bond here. This towards selenium. Okay. Typical ene reaction. This is an ene reaction. Your product will be double bond. This carbon is connected to selenium. Double bond to O. That become OH. Okay, that will be the first step product, which is an ene reaction. This is an ene reaction. Step 1. Step 2. That is the product formed in the first step. This is selenium, which is an OH. The double bond O can be written as O minus selenium plus. Double bond O can be written as O minus selenium plus. You know, selenium oxide undergo 2,3 sigmatropic rearrangement. Selenium oxide undergo 2,3 sigmatropic rearrangement. Okay, this allylic carbon 1, 2, 3, 1, 2. What will be the reaction? O minus will make a pi bond, sigma bond here. This towards here, this back to the selenium. So your product will be between 1 and 2 a pi bond. It's a carbon. This carbon is connected to oxygen. Oxygen is connected to selenium. OH. SCOH. SCOH. Okay. Then followed by hydrolysis or workup. Hydrolysis. H2O bar H plus. Hydrolysis. This is converted into double bond OH. That means 1, 2, 3 allylic carbon is oxidized to OH. Oxygen selenium bond can be cleaved by using oxygen selenium SiO. We discussed some reagents also, or simple hydrolysis also. It is converted into OH. So the mechanism involves two steps. First step is an ene reaction. Second step is selenium oxide undergo 2,3 sigmatropic rearrangement. So ene reaction followed by 2,3 sigmatropic rearrangement. That is the mechanism of the reaction. So wherever SiO2, the reagent SiO2 oxidize allylic hydrogen to an OH. So the last topic, metallocene reaction. Metallocene reaction. Similar to the ene reaction. Instead of hydrogen, metal, magnesium or palladium is used. Okay, instead of hydrogen, metal, magnesium or palladium is used. For example, this is an allylic system with hydrogen. Okay, instead of this, hydrogen can react with a heteroenophile like a carbonyl compound under thermal condition. This is an ene reaction. In metallocene reaction, instead of this hydrogen, a metal like magnesium, for example MgBr, Grignard reagent, a metal is there like magnesium or palladium on reaction with a carbonyl compound under thermal condition. What will be the reaction? First condition thermal, second condition followed by hydrolysis. What will be the reaction? Same ene reaction. Okay, this carbon metal sigma bond shifted towards here, this towards the carbonyl carbon, this towards here. So your product will be double bond carbon. This is O minus MgBr. Here two substituents are there. Followed by next step, hydrolysis. H2O bar H plus, hydrolysis. OMgBr is hydrolyzed to OH. So that will be your final product. Okay. So instead of hydrogen, here a metal, magnesium or palladium is used. Reaction similar to the ene reaction. Followed by hydrolysis, and alcohol will be your final product. So please write another question. This type of reaction is called a metallocene reaction. Another question. A cis-membered ring. Okay, here a double bond. Here MgBr. Next step, pH, C double bond to OH followed by hydrolysis. What will be the reaction? 1, 2, 3. This is allylic carbon. At allylic carbon, a metal magnesium is there. What will be the reaction? This carbon magnesium bond make a pi bond here. This towards the carbonyl carbon, OMgBr. So your product will be the cis-membered ring as such. Between these two carbons, a pi bond. This carbon is connected to the carbonyl carbon O minus MgBr plus, and here a pH is there. Next step, hydrolysis, so that your final product will be double bond OH pH. OH. Yes. So that will be your final product. Okay. So this type of reaction is called metallocene reaction. So write some homework. Remaining question you can do it as a homework. Homework question. First question. A 6-membered ring. C double bond O H double bond MgBr 1 2 3 allylic carbon containing an MgBr. It's an intramolecular reaction. Second question MgBr plus first condition thermal, here also second condition H plus. Sometimes H plus is not given in the question. You have the freedom to choose H plus from the medium. Okay. Then third question. Instead of hydrogen, MgBr plus double bond. First condition thermal. Second condition CO2 H plus. You know Grignard reagent react with the carbon dioxide to form carboxylic acid. Okay. In the first step, a Grignard reagent will be OMgBr on reaction with the carbon dioxide. Carboxylic acid will be your product. So that's about these 3 questions. You can do it as a homework. So we can officially wind up pericyclic reaction. All the aspects, cycloaddition, sigmatropic, group transfer, everything that we discussed. So you can practice all the previous questions. The peculiarity of organic chemistry is we have to study all the topic. Then always you can expect a coupled question. So missing a topic is not a good habit. So studying all the topic, practicing the previous question, stereochemistry, regioselectivity, all these are important factors. So we can officially wind up pericyclic reaction. Wishing you all the best.